Imagine you are floating in deep space with no spacecraft, no suit, just you and the universe stretched out in every direction. From this far out, the cosmos looks beautiful, quiet, and endless. The longer you stare at it, though, the more you start to realize something is genuinely wrong. That dark between the stars is not empty. It is full of things you cannot see, things that have been waiting out there longer than Earth has existed. Over the next 20 minutes, you are going to understand why the universe is not a peaceful place. It is a cosmic horror show, and we just happen to live inside it. We will begin with the biggest monster ever, weighed by humans, a black hole called TON 618, sitting 10.4 billion light-years from Earth. Its mass has been measured at 66 billion times the mass of our Sun, and that second word is worth repeating, because most people misread it the first time. 66 billion solar masses, not million, which is so vast that astronomer Andrew King has argued the object sits at or beyond the theoretical limit for how massive a black hole should ever be allowed to grow. Its event horizon, the boundary past which nothing returns, stretches roughly 1,300 astronomical units across, wider than our entire solar system several times over. Because TON 618 sits 10.4 billion light-years away, what we are observing is the object as it existed 10.4 billion years ago. The version we can see is ancient history, and we have no way of knowing what it has become since. TON 618 is far away, and that is the only thing that makes it comfortable. The real horror is closest. 4 million times the mass of our Sun, sitting at the center of our own galaxy, is a black hole called Sagittarius, a star. The 2020 Nobel Prize in Physics was awarded for proving its existence, and Andrea Ghez, who shared the prize, described the discovery this way. The star S02 is the star that told us there is a supermassive black hole at the center of the galaxy. Every star in the Milky Way, including the one we orbit, has been circling that monster for 4.5 billion years. Closer still, and far more unsettling, is the closest known black hole to Earth, which sits just 1,560 light-years away. Its name is Gaia BH1, and the astrophysicist who discovered it, Kareem El Badri, summed it up like this. Take the solar system, put a black hole where the Sun is, and the Sun where Earth is, and you get this system. A Sun-like star in a planet-sized orbit around a dead one. That is just the closest one we currently know about, though, and that is the part that should worry you. Astronomers estimate that the Milky Way contains up to 100 million isolated stellar mass black holes drifting through the galaxy, invisible, orbiting nothing, lit by nothing, and they could be anywhere. In 2022, scientists confirmed the first one directly, a rogue black hole drifting 5,000 light-years from Earth through the Carina Sagittarius arm of our galaxy. What nobody expected was that 2025 would bring something stranger. An event called AT 2024 TVD revealed a supermassive black hole, far from any galactic center, tearing apart a passing star. A wandering supermassive black hole, the kind we used to assume did not exist, turned out to exist. Black holes aren't the only things drifting in the dark. In 2023, scientists analyzed 9 years of microlensing data and discovered something most people still haven't heard about. For every star in the Milky Way, there are roughly 20 planets with no star at all. NASA's David Bennett put it like this: Our galaxy is home to 20 times more rogue planets than stars, trillions of worlds wandering alone. Most of them, surprisingly, are Earth-sized rather than Jupiter-sized. Right now, as you watch this, trillions of planets the size of the one you're standing on are drifting through interstellar space with no sun and no warmth. Their surfaces frozen to a few degrees above absolute zero. Some of them may have hosted life once before being ejected from their solar systems, which means what's left of them now are essentially tombs. Space itself isn't just full of dangerous things, though. It's also mostly empty, and not in the metaphorical sense. In 1981, astronomers discovered something called the Boots Void, a roughly spherical region of space 330 million light-years across that should contain about 2,000 galaxies based on average density. It contains around 60. Astronomer Greg Aldering captured the strangeness perfectly when he pointed out that if the Milky Way had been in the center of the Bootes Void, we wouldn't have known there were other galaxies until the 1960s. Take a second to actually picture that. An entire human civilization growing up under a night sky with absolutely nothing in it. According to the illustrious cosmological simulation, voids like boots make up 80% of the volume of the cosmic web, while holding only 6% of the matter, which means the default state of reality is emptiness. Empty doesn't mean still, though, because something is pulling us. The Milky Way and roughly 100,000 other galaxies in our neighborhood are being dragged toward a region called the Great Attractor at hundreds of kilometers per second. We cannot see it clearly because it sits hidden behind the dense star fields of our own galaxy's plane. The Great Attractor itself is being dragged towards something even bigger, the Shapley Supercluster, 650 million light-years away, with a core mass equivalent to over 10,000 trillion suns. Everything you have ever known is being pulled towards something we cannot see clearly, and the thing pulling us is being pulled towards something larger still. None of us know where the chain ends. The only certainty is that we're falling. Here's where it gets philosophically disturbing. Every galaxy, every star, every planet, every black hole I have described so far, when added together, accounts for less than 5% of the universe. The Planck Space Telescope mapped the cosmic budget precisely, and the breakdown looks like this. Ordinary matter, the stuff stars and planets and your body are made of, is 4.9% of everything. Dark matter accounts for 26.8%, something massive, something gravitational, something that has never been seen, touched, or detected directly in nearly a century of trying. Fritz Zwicky proposed it in 1933, and Vera Rubin confirmed it through galactic rotation curves in the 1970s. But 90 years later, we still cannot say what the substance actually is. Dark energy is worse, accounting for 68.3% of the universe, a force pushing space itself apart and accelerating the expansion of the cosmos. 3 Nobel Prize winners discovered it in 1998, and Saul Perlmutter described the discovery as throwing an apple in the air and watching it blast off into space. What changed everything was March of 2025, when an experiment called DSE released its second data release using almost 15 million galaxies and quasars. The result was a 2.8 to 4.2 sigma preference for the idea that dark energy is not a constant. The force may be evolving over cosmic time, which sounds like a technical detail until you grasp what it could actually mean. It could mean the universe is ending in a way nobody thought was on the table. In 2003, 3 physicists named Caldwell, Kamionkowski and Weinberg published a paper describing a scenario known as the Big RIP. The model works like this. If dark energy keeps growing in strength, it eventually tears apart every structure in the universe, and the timeline is brutal. Galaxy clusters disperse roughly 1 billion years before the end. Galaxies dissolve 60 million years before the end. The solar system unbinds months before the end. Earth shatters in the final 30 minutes, and atoms themselves dissolve in the closing fractions of a second. The universe does not go cold under this model. It rips. The new DESI data has placed the Big RIP back on the table as a serious possibility for the first time in 20 years. The universe might end a completely different way, though. The Higgs boson, discovered at the Large Hadron Collider, has a mass that places our entire reality in what physicists call a metastable state. That translates roughly like this. There may be a lower energy version of the vacuum that we could collapse into. If a single point anywhere ever did so through a quantum fluctuation or a black hole evaporation event, a bubble of true vacuum would expand outward at the speed of light. Inside that bubble, atoms would no longer hold together, stars would no longer shine, and the fundamental constants of physics would be different. We would not see it coming either, because nothing travels faster than the bubble itself. By the time anyone noticed, we would already be gone. In 2024, a team led by Zlatko Papic at the University of Leeds simulated false vacuum decay on a quantum computer for the first time, which means the idea has officially moved from speculation to something we can study in a lab. Let's come back to Earth, because the threats here are slightly more measurable. For decades, every astronomy textbook claimed the Milky Way and the Andromeda Galaxy would collide in roughly 4.5 billion years. Then, in August of 2025, a paper published in Nature Astronomy by Till Sawala and colleagues reanalyzed the orbital data using new measurements from the Hubble and Gaia telescopes. What they found was not what anyone expected. The probability of collision dropped to roughly 50%. Sawala himself wrote that the data showed an almost equal probability for the widely publicized merger scenario, or conversely, an alternative one, where the Milky Way and Andromeda survive unscathed. That means we are either going to be torn apart by a galactic collision in roughly 4.5 billion years, or we are not. And the honest scientific answer right now is that we do not know. The sun is more than capable of killing us on a much shorter timeline. On September 1st, 1859, an event now called the Carrington Event slammed into Earth. A massive eruption from the sun traveled the entire sun to Earth distance in just 17.6 hours, far faster than the typical 1 to 3 days. Auroras lit up the sky as far south as Cuba and Hawaii. Telegraph operators were shocked at their keyboards, and a number of telegraph offices caught fire. Here is the detail that should genuinely keep you up at night. A 2013 Lloyd's of London study estimated that the same event happening today would cost the United States alone between $600 billion and $2.6 trillion in damage. The blackouts could last months, which means no power, no internet, no water pumps, no refrigeration for months on end. It has happened before. It will happen again. The only thing we do not know is exactly when. Asteroids are next on the threat list. 66 million years ago, an asteroid roughly 10 to 15 kilometers wide struck the Yucatan Peninsula at 20 kilometers per second. releasing energy equivalent to roughly 100 trillion tons of TNT. Every non-avian dinosaur on Earth died. In August 2024, scientists published a paper in the journal Science using ruthenium isotopes that confirmed something genuinely chilling about the impactor. The asteroid was not local to the inner solar system. Co-author Christian Koberl summed up the conclusion bluntly when he stated that the new ruthenium isotope data clearly show that the Chicxulub impact body was a carbonaceous asteroid that originally formed at a greater heliocentric distance beyond the orbit of Jupiter. Translation: something originating in the outer solar system arrived at Earth and wiped out 75% of all life. Another one is on the way. On April 13th, 2029, an asteroid called 99942 Apophis will pass approximately 31,600 kilometers above Earth's surface, which is closer than the satellites broadcasting your phone signal. When the object was first discovered, scientists calculated a 2.7% chance of impact, the highest danger rating ever assigned to a near-Earth object. Radar observations later in 2021 ruled out a collision this century, and that is a genuine relief. What has not changed is that Apophis will be visible to the naked eye from Europe, Africa, and Western Asia during the flyby. Most people in your life have no idea this event is even on the calendar. Even stars in our own galaxy can do damage from thousands of light years away. On December 27th, 2004, a magnetar called SGR 180620, an ultra-dense neutron star with a magnetic field a quadrillion times stronger than Earth's, released a giant flare. The total energy released was greater than any star-related event ever recorded outside our solar system. The shockwave reached Earth from across the galaxy and briefly expanded our ionosphere. The starquake responsible would have registered magnitude 32 on the Richter scale. Here's the line that should genuinely terrify you. Physicist Robert Palmer wrote in Nature that if the event had happened closer, it would have resembled a short, hard gamma-ray burst. If a magnetar flare of that magnitude ever happens within 10 light-years of Earth, the ozone layer would be stripped from our atmosphere. Every surface ecosystem would collapse, and the planet would essentially be cooked. A Wolf-Rayet star called WR104 sits 8,400 light-years away in the constellation Sagittarius. For decades, astronomers thought its rotation axis was tilted within 16 degrees of pointing directly at Earth, which meant that when the star eventually goes supernova, its gamma-ray jet might be aimed straight at us. In 2025, the Keck Observatory finally settled the question and found that the system is actually tilted between 30 and 40 degrees out of our line of sight. This means Earth is probably not in the firing line. The word probably is doing a lot of work in that sentence. Two final facts should genuinely reshape how you look at the night sky. The observable universe is roughly 93 billion light-years across, and the universe itself is 13.787 billion years old. Because of dark energy, approximately 94% of the galaxies we can currently see are already beyond what astronomers call the cosmic event horizon. Any signal we send to those galaxies today will never arrive. We can only see them at all because their light was emitted long ago, which means the universe is, in a real sense, a museum of light from places we will never reach, frozen in time, drifting permanently out of contact with us. The farthest object humans have ever sent is Voyager 1, launched on September 5th, 1977. As of March 2026, the spacecraft sits 5.8 billion kilometers from Earth. In November of 2026, Voyager 1 will become the first spacecraft ever to reach a distance of 1 full light day from our planet. Project manager Suzanne Dodd at JPL described what that distance actually feels like in practice. If she transmits a command at 8 in the morning on a Monday, Voyager 1's response arrives back to her on Wednesday morning. Its nuclear power source is fading at about 4 watts a year, which means by roughly 2030, the spacecraft will fall completely silent. It will keep traveling, though. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445, carrying a golden record curated by Carl Sagan's team, containing sounds and images from Earth, addressed to no one in particular. So this is the universe scientists have actually mapped, not the pretty version printed in textbooks. Black holes, larger than our entire solar system. Trillions of starless planets drifting through frozen darkness. Voids of empty space so vast that any civilization inside them would never know other galaxies exist. A gravitational current pulling us towards something hidden behind our own galaxy. A reality composed of 95% substances we cannot identify. Stars capable of sterilizing planets across thousands of light years. Solar storms that can black out continents for months. Asteroids capable of ending species. And underneath all of it, the possibility that the rules of physics themselves are unstable, that dark energy is evolving, and that the universe could end at any moment in a wave we would never see coming. The pretty pictures NASA shows you are real. Everything else I just described is also real. The universe didn't ask whether anything would survive it. It never has. It just keeps going. And so do we. For now.